Hi everyone, welcome to our webinar today. The topic of this webinar is Energy Storage Market Updates and focus on modeling for system design. And this webinar is a presentation of the Energy Storage Technology Advancement Partnership, also known as STAP. STAP is supported by the U.S. DOE and Sandia National Laboratories and is managed by the Clean Energy States Alliance. And as our host for this webinar today, we have STAP Project Director Todd Olinsky-Paul. Before I pass this over to Todd, I'd like to go over a few quick housekeeping notes. All of our participants for this webinar today are in listen-only mode. That means that you can hear us, hopefully, but we can't hear you. You have a couple of options to connect to the audio portion of the webinar. You can either call in using your telephone, or you can use a computer, microphone, and headset. A very important note, we ask that you please submit your questions as you think of them throughout the webinar by typing them into the question box on your webinar console and hitting send. And we will be reading through your questions as you send them in. We will have time for a Q&A at the end of the webinar, and we'll get to as many questions as we can. But you should type your questions in when you think of them. Don't wait till the end. That just increases the chance that we'll get to your question. And finally, this webinar is being recorded. You'll find a recording of this webinar as well as all of our previous webinars on our website at cesa.org/webinars. And another note, we also have on your webinar console, you'll see a handout section. We have attached a PDF that summarized a previous market brief webinar that we did in September of 2015. And you can look at that now or later, but I just wanted to draw your attention to that. And with that, I'll pass this over to Todd.
Okay, thanks very much, Samantha, and welcome to the webinar, everybody. This is an STAP webinar, and my name is Todd Olinsky-Paul. I'm the project director for our Energy Storage Technology Advancement Partnership, STAP. And I'm going to do a brief introduction of our project, and then we will introduce the speakers and go into the main portion of today's presentation. Can you advance the slide, please, Samantha? I want to just repeat, I know Samantha just said it, but if you look on the webinar console, you'll see where it says handouts. If you open that and just click on the PDF, you will see a market summary that was put together, compiled from a previous webinar that CES was kind enough to do with us the end of last year, and you might want to take a look at that as we go through the market update portion of this webinar. I also want to thank Dr. Imre Zsuk at US DOE Office of Electricity for sponsoring and supporting our energy storage work, and Dan Borneo at Sandia National Laboratories, where we have a contract to conduct this work. Next slide, please. I just wanted to give a little background on CESA and STAP for those of you who haven't joined us previously. CESA is Clean Energy States Alliance. This is a nonprofit. We're based in Vermont, and we work primarily with states to support clean energy and energy storage work with states, supporting their program and policy development, and also demonstration projects in the realm of energy storage, and then just generally with clean energy, supporting their efforts to develop and manage programs. With regard to this particular project, STAP, this is conducted under contract with Sandia. Our primary role is to bring states to the table to partner with DOE and Sandia to create joint federal-state energy storage demonstration projects. And so we've worked with quite a few states over the past few years. As you can see from the map here, we're actively working with states all over the country and developing projects supporting state policy development and program development around energy storage. So that's very exciting. I won't go into detail, but you are welcome to visit our website. Next slide, please. If you do want more information about our STAP program, this is a screenshot from the website, and you can see there's a red circle there around the sign up for our email list. This is where you would go to sign up to receive notices of future webinars or other upcoming events and reports and so forth. Also, on the left-hand column, you see there's a red arrow pointing to our webinar archive link. That's where you would go to review webinars that we've produced. We've produced quite a number over the past several years. They're all archived in their entirety and as a PDF of the slides. So you can either watch the webinar with the audio, or you can just take a look at the slides by going to that webinar link. And in answer to the question I always get, yes, this webinar will be posted as well. It doesn't happen instantly, but within a few hours usually, or at most a day of the end of this webinar, you'll be able to find it in its archived form at that link. Next slide, please. So I want to introduce today's guest speakers, and then we will start the presentation. And I also want to remind everyone that we will address questions after the presentation, so please send those in as you think of them, and I'll be looking through those and queuing them up for discussion. So we have three presenters from Customized Energy Solutions today. We have Jacqueline DeRosa, the Vice President of Technologies. We have Vinayak Walimbe, Director of Financial Services, and we have Erik, Paulson, Vice President for Wholesale Market Services. And so I'll give a brief bio for each. Jackie joined Customized Energy Solutions in 2007. She assists her clients to evaluate and integrate emerging technologies into the energy markets. She's an expert in the energy regulatory arena and wholesale market rules, and she has over 25 years of experience in the energy industry. She worked for the California ISO in the areas of market design and account management, and has also worked internationally on energy regulatory reform and restructuring matters for the U.S. Agency for International Development. Jackie also worked in project development for an independent power producer and has worked for the Federal Energy Regulatory Commission. She holds a BA from Rutgers University and an MBA from George Washington University. Following Jackie, we'll hear from Vinayak, who began working as a senior consultant at Customized Energy Solutions and is now a director of financial services. He's a chartered financial analyst with extensive experience in financial modeling and advisory, and his work includes providing investment analysis and developing proposed price structures for electric power projects. Vinayak also conducts market analysis to evaluate competitive energy market opportunities for energy, capacity, demand response, and ancillary services, which will be obviously a topic of discussion today, as well as evaluating issues associated with renewable integration. He holds a Master's of Science from Georgia Institute of Technology in Atlanta, a Master of Engineering from VJTI Mumbai, and an undergraduate degree in electrical engineering from Walchand College of Engineering, Sanglai, India, and I'm sorry if I mispronounced any of that. Finally, we will hear from Erik Paulson. He is responsible for the company's services related to the wholesale electricity markets, which includes managing and scheduling generation assets in the various RTOs and ISOs, managing the electricity purchases and the electricity market activity for large users, including municipalities and industrial customers. Erik joined Customized Energy Solutions in May of 2005 as the Director of Regulatory Affairs for PJM. In this role, he provided market updates and information on market rule changes to many clients in the PJM service territory. So those are our speakers, and I think at this point I will hand the presentation over to them. Just a reminder to everyone to please send your questions in by typing them into the console, and we'll get to as many as we can at the end of the presentations. So Jackie, over to you.
Thank you very much, Todd and Sam. Hello, it's a pleasure to be with you this afternoon. Our presentation will provide insights into the areas that one would need to consider when developing a storage project and bringing it online. We'll look at how to model a storage project, talk about state of charge management, and explain how to participate in the ISO market. Customized Energy Solutions was established in 1998. We're a privately owned corporation based in Philadelphia, Pennsylvania, with offices throughout the country. and also in Pune, India. We're also expanding into other international markets, including Mexico and Japan. And Sam, I'm trying to move the slide, but it's not going.
Sure. Oh, there you go. Looks like it's working.
Okay, thank you. CES's various business lines cover many aspects of the energy industry, which you can see here on this slide, and we aim to be a full-service provider for consulting and market operations services so that we can take projects from their inception all the way through settlements and billing. CES is a recognized leader for integrating energy storage into the regional energy markets in the United States and internationally. We've performed technical and economic evaluations, aided in project development, due diligence, investment evaluations by utilities, financial institutions, and project developers. So our in-depth knowledge of the market rules and regulatory arena allow us to provide regulatory support as well as the most up-to-date market impact and pricing analyses. In addition to scheduling over 4,000 megawatts of generation load and demand response from our Market Operations Center in Philadelphia, we also schedule energy storage resources in multiple ISO and RTO markets, which are listed here on this slide. Our practical experience with day-to-day operation of energy storage facilities in competitive energy markets provides CES the CES team a base that sets our emerging technologies consulting services apart from other providers. As the RTOs and ISOs were developed way more than a decade ago, starting with FERC Order 888, the initial designs focused on participation by conventional generation. New technologies such as energy storage were not initially contemplated. Progress has been made since our last presentation in the fall, and today each one of the ISOs and RTOs has a stakeholder initiative focusing on integrating energy storage into their market designs. And here I would like to give a special thanks to the Department of Energy for recognizing energy storage's potential and initiating a viable industry that really can add tremendous value to the power grid and to consumers. I'll give a brief update now on what's happening in the ISO and RTO markets related to energy storage. And as Todd and Sam mentioned, this is only a brief update. We'd already provided a more detailed discussion of the market rules in the various ISOs and RTOs and what's happening in the states. So today I'm only going to give a quick update to let you know where to focus and what ISOs and what's the news. So first and foremost, and the most important thing that's happened very recently is that on April 11th, FERC initiated a new proceeding requesting comments regarding organized market rules for electric storage resources. FERC simultaneously issued letters to each of the 6 ISOs and RTOs in their jurisdiction seeking information from each regarding potential barriers that would prevent electric storage resources from participating in capacity, energy, and ancillary services markets within each RTO and ISO. FERC is interested in the eligibility of electric storage resources to participate in these markets, the technical qualification and performance requirements for market participants, the required bid parameters, and the treatment of electric storage resources when they're receiving electricity for later injection to the grid. This is huge. FERC set a May 2nd deadline for the ISOs and RTOs to respond to the data requests, and comments from interested participants are due on May 23rd, 2016. There's additional dockets at FERC too, where energy storage is featured, including rulemakings involving frequency, response, and voltage support, both very important areas to energy storage. And FERC is also pursuing changes in the interconnection process, again, highly relevant to energy storage projects. I'll now give an update on what's happening at the various markets. And just to reiterate, I will not go into the same level of detail in our previous presentation. This is just an update. That way we can hear from Vinayak and Erik within the hour. Each one of these topics could take days. but I do want to highlight where the focus is and what the news is. So again, California, let's start where it's happening. California, in general, is farther along than the other markets in its implementation of market design features to integrate energy storage. The California ISO has implemented a design feature called the non-generator resource, and that entity can participate in the energy and ancillary services markets. In addition, energy storage can participate in the wholesale market as a demand response resource. The California ISO continues to pursue enhancements to the NGR model, and the Board of Governors earlier this year approved an ISO proposal to further enhance the NGR design and implement additional features in the proxy demand response design to consider energy storage from behind the meter. The ISO board also approved an updated design to aggregate resources that are in front of the meter in January of this year. Earlier this year, the ISO board approved the flexible ramping product, which will go into place later this year, and this is a product that energy storage is qualified to offer. At the state level, there continue to be pivotal changes that impact the growth of the energy storage resources in the state. Since the last time we spoke, the utilities have made their filings with the CPUC for the 2016 energy storage solicitations. Awards were made for and applications were filed for the 2014 projects. SCE pursued a preferred resources pilot earlier this year. Awards were made in the 2016 demand response auction mechanism, and the 2017 DRAM is underway. The energy storage proceeding is well underway, and topics such as submetering and rules for multi-use applications will be addressed. Hundreds of megawatts are coming online, and thousands are in the generation queue. Next, we'll move on to what's happening in ISO New England. ISO New England posted an energy storage paper in January of this year and then updated it in March. And they outlined how energy storage resources can participate in their market. While this isn't a stakeholder initiative per se, it's a start and it's something to be aware of. Also, just as a note, the ISO New England did increase their regulation requirement recently by about 10 megawatts, and sometimes 20 megawatts in certain hours. Also to be aware, MISO. MISO also began a stakeholder initiative regarding energy storage in 2015 in January. And MISO has collected input from stakeholders and is proposing a phased-in approach to further integrate energy storage and wants to prioritize their initiatives while balancing costs and benefits. So in the near term, they'll pursue some relatively straightforward and low-cost items that require minor tariff and BPM changes. And then, moving into 2017 to 19, they'll address issues that require more complexity. In SPP, in January of this year, a proposal was brought forth to create a new stored energy resource type exclusively for short-duration energy storage resources to participate in the frequency regulation market. This topic will be discussed again in May, and it's not likely that anything would be implemented until at least 2019. But again, highlighting that this process is being considered and it's underway. In ERCOT, since we last spoke, the ERCOT employed the Brattle Group to conduct a cost-benefits analysis for the fast ancillary services design, which showed significant benefits as soon as the first year of deployment. Despite those demonstrated benefits, there's still not yet consensus to move the proposal forward, but it's in the works. Again, if this was approved, it wouldn't be implemented until at least the 2019 timeframe. New York ISO initiated the Energy Storage Integration Initiative at the March 1st Market Issues Working Group, and again discussed this at the April 18th meeting. The ISO has outlined the asset classes that can currently accommodate energy storage, and it's requested that stakeholders submit questions and suggestions on how to better integrate storage in the wholesale market. Like MISO, they'll probably be prioritizing what they can do first and what would take more resources for further integration. They're also considering how to best implement the behind-the-meter storage to marry with the New York REV process. In PJM, since we last spoke, they implemented the cap on the Reg D resources. That's from 200 to 300 megawatts. This was done in December. Now, the amount of the storage does exceed the cap in some hours, so that this is still an issue, and the regulation task force continues to meet monthly. The prices have since gone down in PJM as a result of the cap, but there is a very concerted effort to study this issue and find a solution. Separately, it might be worthwhile to know that Mensa has initiated a stakeholder process with the Markets and Reliability Committee at PJM, and a special meeting was held this month to look at interconnection issues and the inability to net inject from behind-the-meter battery resources. And there will be another meeting on that on April 28th. So there's just a lot happening, and the reason I mention all these things is that it's important to understand these market rules as one pursues interconnection and development of a project. And that's why I'll turn it over to Vinayak next, who can talk about how to avoid the pitfalls and what's important to consider when looking at developing a project in an ISO or RTO market. Thank you.
Thanks, Jackie. So as Jackie mentioned, there are various rules and regulations for storage to participate in different markets. And as you know, storage is an emerging technology. There are a variety of technologies out there. Most of them are not really mature technologies. The rules are changing, so there is a greater uncertainty in deploying energy storage project today than other conventional or renewable projects. So how do you make a decision in this uncertain market and through new technologies? To make this decision making easier for project developers or technology developers, CES has designed tools to analyze energy storage applications called COMETS. It stands for Competitive Market Evaluation Tools for Storage. The tool essentially takes into account different market rules and regulations and tries to quantify that how storage will get operated for different applications in different markets, and analyzes economics of a storage project for that particular application. And the tool is available to license as well as to analyze a specific project. So today I will briefly talk about one of the tools that we have, which is common and the most popular, which is for frequency regulation. As Jackie mentioned, in different markets, there are rules being placed, and the breakout really happened when the order FERC 755 came in, which is for pay for performance, where storage assets essentially get paid better due to their better performance characteristics. So what this tool does, it takes into account the regulation signal that system operator or ISO gives, and then simulates the response of a storage to calculate how it will perform for that market, which will be used to estimate the revenue or the expense for that project. So essentially, in the what we call in the regulation signal model, so there are 4 basic pieces of it, which then gets used in the financial model, which is a different module of the COMETS. So first one is the resource physics, where we take the characteristics of a storage resource, whether it's power rating, duration, efficiency, ramp rate, and so on, or the cycle life curves. Each ISO or market has a unique way of dispatching a regulation asset. So there is a system-wide signal called ACE, or area control error, which is a function of a supply and demand mismatch, and that affects the frequency. And that ACE gets converted into resource-specific signal called AGC. So we have simulated that for each market. And then we simulate the resource's response to that AGC signal. The response depends on its technical characteristics, its energy capacity and power rating and so on. And also how the project developer or the owner wants to operate the asset. And the output of this thing is the performance metrics, be it a mileage or a performance ratio, and I'll explain a little bit what these are in the next few slides. But they are essentially metrics to calculate the revenue for the asset from the price forecast or from the clearing prices. So once we simulate, the tool also has the price forecast of regulation prices in different markets, and those price forecasts combined with the performance score will give us a revenue. And along with that, we can also find metrics like how many cycles and what the depth of discharge these cycles are being done by the resource in this market. And that can be also used to decide an operating strategy or optimize an asset or come up with the optimal size of the asset. And all these metrics can be put into a financial model to decide the investment merits using NPV or IRR, whatever the metric developer likes to use. So this is an example of different signals, and these signals are either 2 second, 4 second, or 6 second, that kind of frequency. So there is a lot of data to handle, and Erik will explain some of the operational difficulties of managing such assets. And as you can see, the different market signals look quite different from each other. That means a single resource behaves differently in different markets. That means that it earns a different amount of revenue, it degrades differently, hence needs to be replaced differently in different markets, and that has an impact on the warranties that a technology provider is providing. Also, when a developer wants to decide on the optimal asset, each market may give you a different size, optimal size for given capital cost or the performance. So the tool helps you decide all that, and more importantly, it also helps you decide what's the best way of operating the asset. And this is one example. So in PJM, what you should see here in as a red line is the signal that a resource receives, called Reg D, and the blue is what the COMETS has simulated. And in some of the intervals that you see, that blue signal is not following Reg D signal, and that's because the resource is going out of charge, and that affects the performance score. So if you see, the performance score is just about 92%. More importantly, if you look at the histogram of state of charge, it's towards almost the empty state. That means it affects the life and life of the asset. Performing this way would be much shorter. So we have designed an algorithms where asset can perform better, and this is one of the strategies. Now what you want to optimize for changes. So for example, one may want to optimize the revenue over the life of the asset. But given the recent changes in PJM, the maximizing performance score has become more important because it is directly affecting whether the resources are getting cleared or not. So to optimize, one needs to understand the markets well as well as the technologies well. So this is one of the strategies where we manage state of charge and also a communication delay, and some of you may be familiar with how PJM measures that. So that also affects the performance. So now the performance score has improved to 97%, and more importantly, state of charge is has moved towards the middle, indicating the life of the asset has improved. So this is the operating strategy that one may implement in the field. Of course, there are lot of practical issues to take care before we implement such a strategy. As I explained, or and Jackie mentioned, the market rules are changing, so one needs to keep up with the market rules. That means the way you are operating or managing state of charge needs to change as well. And Erik may touch upon some of that we also have looked at different algorithms given the changes in the market. Performance score as well as the revenue, expected revenue also changes depending on the resource dynamics in the market and how many new resources are coming in. Or also the market size gets affected because of renewables. So one needs to have that market knowledge and such tools like COMETS to optimize between life and the revenue, or to understand the warranties that a technology provider is providing. So once you take these and when you want to implement that into the field, we've faced quite technical challenges. And when you design an algorithm, that also needs to be taken care of. So for example, a telemetry or communication plays an important role in getting the right performance. And Erik can talk in depth about all that because we are managing state of charge for an asset and also scheduling a storage assets. So with that, I'll hand over to Erik.
Great, thanks, Vinayak. Appreciate it. And the idea of this is just to give a brief overview of some of the aspects we've seen of storage facilities participating in the markets, really some of the hurdles that they've either run into and had to overcome. As Jackie had indicated earlier, we as a company manage about 8 or 10 different storage facilities today in the markets. Quick little bit of history. Prior to being at CES, I was actually the manager of market development at PJM, and I remember sitting there about 10 or 12 years ago when a couple of folks from a certain flywheel company wanted to meet with PJM, and they met with me and brought up this idea that they want to have a storage resource participate in the regulation market. And I remember scratching my head sort of saying, you want to do what? And from that started talking with the higher up folks at PJM and figuring out how we were going to implement these, and amazing how far the markets have come today on that. So again, we'll keep this fairly quick because I know we're getting short on time. These are topics we could probably talk days about, but a few of the high-level areas to get into the ISO regulation markets. Storage resources do need to be registered as a market participant or can contract out to a third party as that market participant. The ISOs will only deal specifically with market participants or with members. Sometimes it's beneficial for a storage owner to become a member themselves. Other times they will utilize a third party, but that hurdle does need to be met. Also, The interconnection processes will vary by ISO, and as Jackie mentioned, their rules are being reviewed, but most of the time a storage resource will have to follow a very similar interconnection process as a generator would follow, which can take in the neighborhood of 12 to even 18 months. So there is some lead time to account for there. The exception to that can be if a resource is operating behind the meter, meaning it's finding a consumer or a load and it's basically serving that load first. The restriction there, though, is it may limit the amount of storage you're able to provide because you can't export out to the grid. And then lastly, telemetry requirements. The ISOs all want to see what the storage facility is producing at every instant in time. They need to have very near real-time information to be able to calculate their performance scores, and typically they need to establish private network connections or some sort of virtual connection to the facilities, and again, that can take some lead time to it. We've seen several instances where storage developers have not realized that, waited till the last minute, and basically ready to come online, but then have to wait several weeks in order to get that telemetry in place. Lastly, to be in the regulation markets, each of the ISOs require some sort of qualification. As an example here, PJM specifically requires resources to pass 3 consecutive qualification tests. Those do require advanced scheduling. They do have to be scheduled one day sequentially after each other. So again, it takes a little bit of prior notice. Also, resources that maybe are starting in the market at one level of participation and then want to add additional capability later on, they would have to go back through that qualification process in order to add the additional capability. So it can be a little bit of a trade-off of, do you wait till you have the entire facility online, get it registered and certified all at once, or do you try to build the project out in phases? And then if you do build it out in phases, you may have a little bit of additional time while you qualify the additional phases. And then just as an example on the slide there is the actual regulation test signal that PJM issues for storage facilities. It is a signal that's posted out on the web, so you can download it and actually use that as a sample or as a test signal for yourselves to make sure facilities are able to follow. Then once you're participating in the market, just to give an idea of what's required day in and day out, most of the ISOs have either a day ahead or real time or some sort of hourly clearing process. So normally some steps have to be taken in the ISO scheduling systems to keep those resources in the markets. Some of them do have the capability of just setting one offer and letting it roll over and roll over. But then all of the markets, you'll need to be monitoring what the clearing results are and potentially adjusting the resource availability into the market. For example, if an inverter goes down or a series of cells go down, you have to make sure that you're updating that information to the ISO. So typically there is some sort of 24-hour monitoring and scheduling function that's needed along with these resources. And probably a little bit hard to see on the screens there, but what that is a screenshot of the PJM scheduling system where they post the results out each hour. This happens to be the public results, but they also post individual results out to each resource so that you can see how much has been assigned. I mentioned the upfront requirement to get telemetry in place. What I'm showing on the screen here is just an example of some of the information that typically flows back and forth between the resources and the ISOs. You generally would have a megawatt output. You'll generally have the regulation signals that are coming from the ISO out to the facility, and then oftentimes there are feedback of those signals going from the facility back to the ISO. One note in here is a field called a bias. As Vinayak had mentioned, often when doing state of charge management, there can be some biasing or adjustments applied to the telemetry signals or to the regulation signal. That's an example there of another data point that's going down to the facility. Performance score, one of the things I wanted to talk briefly about for operations is the significance of the performance scores. In almost all of the markets, those performance scores factor directly into the payment stream. And in some of the markets now, specifically PJM, they also are used to determine the rank order for the clearing process. And so what that can mean is if a particular ISO has basically more storage than the caps allow for a given hour, you can have resources that have relatively high performance scores yet are not being picked up, meaning they're sitting there idle and not earning revenue for those hours. So it's becoming more and more critical to ensure the facilities have as high a performance score as possible. The numbers on the screen there actually come from a recent presentation PJM had made showing average and the maximum performance scores that they've seen on an average across those monthly bases. Then just a little bit more detail on how specifically PJM calculates the performance scores. They actually break the response of a facility, or they break the performance score calculation down into 3 separate categories where they have an accuracy, a delay, and a precision piece. A fair amount of detail goes into how they calculate each of those. They calculate them each on an hourly basis by looking at 10-second snapshots across that hour. And again, all the data that they're using comes from that telemetry stream, making it very important to make sure that there are not any delays in that telemetry stream or any latency between the facility and the ISO. Because that can significantly impact performance score. Also, it means as you're implementing the telemetry, you want to be using as few components as possible between the ISO and the site to limit any time delays in handing off points between those components. So how do you make all this happen? Most of the time, we've seen storage facilities be managed or monitored by some sort of market operations center. Some of the ISOs for facilities that are providing regulation actually require there to be a 24-hour operator on standby, and again, that's because these regulation facilities contribute significantly to the reliability of the grid, and so it's very critical to the ISOs that they're able to get a hold of someone if there's any problem with those facilities. One of the last pieces of the ongoing participation requirements important to the resource owner, obviously, is the settlements tracking. There's a lot of data flowing back and forth, and these are typically hourly markets. Generally, the ISOs are very good at capturing when a resource is assigned and what it should be paid, but they're certainly not perfect at it, especially as these markets are new. So it is very important to resource owners to be setting up their own system or outsourcing to another party to build a system or using a third-party system that tracks the settlements so that you can estimate what you should be getting paid and then compare that to the ISO bills at the end of the month. I apologize, I know I've gone through this a little bit quickly, but we're running short on time here. So I think I am at the end of the slides, and Todd or Sam, I'll turn it back over to you to guide us in the questions.
Okay, thanks very much, and thanks to all our presenters. I do want to try to get to as many questions as we can, so let's go ahead and just jump in. And you don't each need to weigh in on each question, so let's try to we'll try to get to as many as possible. If just maybe one of you could address each question, if that works, that would be great. One thing that was asked that I can address says the speaker mentioned there was a more detailed presentation previously. When was that, and where would the recording be? I believe it was in September. It was in the fall last year, and the recording, as I think I mentioned in the introduction, is archived on the CESA website and is accessible from the STAP page. We showed that link earlier, and at the maybe Samantha, you could put up the slide with the links on it so people can jot it down if they want to, where to go. Also, the information that was presented in that earlier, thank you, Samantha, there you go, the webinar archives link is right there. And also the information presented in that earlier presentation is condensed and compiled in the handout, which is available for download right now from the webinar console. So if you didn't get that, look for the handout and download it from your webinar console. Okay, first question for the panelists. How are modeling teams currently solving the lack of reliable 15-minute and sub-15-minute interval data for end users? And this is primarily for behind-the-meter systems. When designing energy storage systems in developing markets where this data oftentimes is simply not available or does not exist.
Yeah, so maybe I can take that. So that is a challenge. What we have done is through our network, we at least have, so this is for behind the meter. So for example, you need load data. So we have at least created a sample load curves for a typical customer, like an industrial user or an hospital or a hotel. So those kind of load curves we have gathered. But that is a challenge when we are looking at one specific project and the data required is not there. We have, at least in some few international projects, kept our own meters there for a few months and recorded the data before doing the analysis. So that's all one can do.
Yeah. Okay. Good. Somebody wants to know what the C rate is. There were, I guess, in one of the slides, and I don't recall which one, referenced the C rate. Could somebody explain what that means?
So I'm not the expert in that, but I can speak to it. I don't know which slide mentioned that, but so when you have a 1 hour system, that's a 1C system. If you have a 30-minute, that's a 2C system, meaning you can charge it at a twice rate, and hence can charge the storage from 0 to 100% in 30 minutes. So that's a 2C system. 2 hour battery is a 0.5C system. So it's just 1 over the duration of the battery. If that makes sense.
Great, thank you. That's great. So next question, is there any relation between the market signal for frequency regulation and the actual energy price, like LMP, in the market?
So I would say no. They are generally co-optimized, but the signal is really a function of a mismatch in supply and demand, which is very at very short duration, in a matter of seconds, like 2 seconds and 4 seconds. And LMPs are on an hourly basis. Erik perhaps can comment more on that.
Yeah, Vinayak, the only thing I might add is where you might see some correlation is if there's a large disturbance on the grid, such as a nuclear unit tripping offline, and at that point the grid operator has to rely very heavily on the regulation. You'll see it holding at a maximum signal, and at the same time you'll be seeing the energy prices increase, again, to fill the hole for the resource that's tripped offline. But other than that, as Vinayak stated, the regulation's moving so quickly, whereas the energy markets are 5-minute pricing, you typically will not see a correlation.
But let me to add though, so we do see in terms of regulation prices and LMPs a correlation, but not necessarily how the frequency regulation signals are. They do not necessarily affect the prices. But in our forecasting for regulation prices, we do look at the correlations between LMPs and regulation prices. So, for example, we see in certain markets capability or capacity prices, capacity regulation prices correlated with LMPs. And that is mainly because the marginal resource could be a gas plant or even coal plant in certain markets. So because of that, we do see correlation, especially with capability prices.
Great. I think this is a related question. Somebody wants to know, during the frequency regulation application, or I guess in frequency regulation, how often is a signal exchanged between the battery and the ISO, and how often is the performance score calculated? And I guess that might have to do a lot with which market you're operating in.
Yeah, this is Erik. I can take that. It does vary somewhat, but the standard is exchanging the regulation signals between every 2 and every 4 seconds. Sometimes it can even be done as low as 1 second, so I guess I should say it's between every 1 and 4 seconds. Again, typically the less time delay or the more frequently you can exchange that signal, the better, because it will help you to maximize your performance score. And typically the performance scores are calculated on an hourly average basis.
Okay, great. Here's a question. I don't know, not sure whether you want to comment, but the question is, can CES comment on PJM's recent recognition that regulation providers are gaming the system by propagating 10-second delays, thus causing ACE oscillation? I have to admit that I'm not familiar with this. Does anybody want to comment on that?
Yeah, so it's the peculiar way the PJM measures it. So it turns out that if an asset is following the signal precisely just with 2-second delay, may get a worse performance score than an asset following the signal with precise 10-second delay. So there would be an asset which is following the signal a little later than some other, and hence it should be less accurate, but it gets better performance score. Because the way PJM measures it, they sample every 10 seconds. I mean, I don't know whether it's gaming the system or not, but that's how the PJM measures it, and hence asset owners may adjust their telemetry accordingly.
I see. So in a wholesale market that is trying to promote and reward higher performing resources, what you're saying is that because of a peculiarity of how they measure it, performance, they may actually be incentivizing slightly lower performance. Is that what you're saying?
But I mean, yes, but we are talking about, all these assets are quite high performing and have an ability to follow the signal quite well. So I don't think it really makes a difference philosophically in terms of whether you are incentivizing less performing assets. I don't think they're really less performing assets per se. I think it's just the way PJM measures it, perhaps to avoid too much data crunching on their part.
I see. Okay, but I don't want to misrepresent the question. The question had to do with the questioner asserts that this is causing ACE oscillation. What is ACE oscillation, and what's the relationship between that and a 10-second delay, or is that a misunderstanding of what's going on?
So I think the question is asking ACE is changing because of that. If you're not following it accurately, then there might be a variation in ACE. So that might be true, but I mean, honestly speaking, I haven't really looked at whether that really causes any oscillations in ACE. So I can't really comment on it. But just intuitively speaking, it doesn't seem that that will cause any significant variation in ACE.
Okay. And what is
Todd,
what
to
is
answer
ACE?
Todd, to answer your question, ACE is the area control error, which is essentially a measure of how much energy the ISO is importing or exporting compared to how much it should be importing or exporting.
Okay, thank you. This is a question regarding the last slide. So, Samantha, maybe you could put the last slide back up if that's possible. The question is, how do you estimate performance ratio in the table that was showed in the last slide? I guess that's not really the last slide they're talking about. There's a slide with a table. There it is, settlements tracking. I think that's what they're asking about. So how do you estimate performance ratio in this table, or do you?
That is a good question. I'm afraid I don't know the exact methodology that you use off the top of my head. There are a few different pieces of information that are posted on PJM's website each hour that let you pull and calculate that. I apologize. I don't have an exact answer to that at this time.
Are you asking the performance score? How do you calculate that? Is that the question?
Was how do you estimate performance? I don't have the question any longer. Performance ratio, I think, was the question.
Okay, so I think it's performance score, and so in PJM, so there are three components to performance score. One is the correlation score, which is simply a statistical correlation between regulation signal, which is Reg D in this case, and a response of a battery or a storage resource. The second component is the delay score, which is a measure of how accurately the signal is being followed by the asset in terms of the time. So it's the absolute value of the delta between the signal and the response. And another one is the precision score, which is which measures the error between the two, the response and the signal, and it calculates. So there is a formula which is 1 minus that absolute value of error divided by how many intervals that you are measuring it. So you have these correlation score, delay score, precision score, and the average of that is the performance score. And there are some nuances to that.
Okay. Thank you. And I know that we're at the end of our hour, but we have a number of questions I'd like to get to. If we could continue for just a few more minutes. There's some very good questions. This one is actually something I'm very interested in, and a lot of people are, in ISO New England. So the question has to do with load reconstitution. Please overview your thoughts on load reconstitution in ISO New England. Will ISO New England add back load and therefore negate any transmission and capacity benefits from energy storage? Does the recent FERC Order 755 preclude such conduct by ISO New England? I should note that what this is referring to is that utilities in ISO New England pay the ISO for capacity and transmission services, and if they can significantly reduce their load during the peak hours, then they are able to reduce their portion of that cost, and that can be very significant. It could add up to hundreds of thousands of dollars annually. So this is a significant potential cost savings that can be attained using storage, but the question is that apparently there's this load reconstitution clause that allows the ISO to add the reduced demand back in as load if it's accomplished using renewable resources that are not dispatchable, and apparently storage is sort of lumped in with that category, if I understand it correctly. So the question is ISO New England going to be doing this? I don't know if anyone knows. And also, does FERC Order 755 preclude it?
This is Jackie. I can try to answer that. That's a very opaque area. As I've researched it a bit for our project with the state of Massachusetts through the Energy Storage Initiative. We are conducting a study for the Department of Energy Resources and the Mass CEC. So our research shows, just as you described, Todd, that the definition of regional network load under the ISO New England Tariff Section 1 General Terms and Conditions includes all load designated by the network customer, including losses, and shall not be credited or reduced for any behind-the-meter generation. So that sentence effectively requires that anything considered behind the meter to be reconstituted for the purposes of determining the transmission payments, pursuant to the OAT, the Open Access Transmission Tariff. And the behind the meter is really not defined anywhere in the Transmission Market and Services Tariff or by ISO New England or by FERC. So I think that the ISO New England Tariff, while it's explicit on its requirement that behind-the-meter generation should be added back to the calculation, it's not consistent with what's included in the transmission owner's Schedule 21s that define their own methodology for calculating local network load. And, looking at just different tariffs or different Schedules 1, we've looked at Green Mountain Power, New England Power, for example, and that definition is different. So in our report, we will make a recommendation that that this issue be defined, that ISO New England define the behind the meter generation, and that the treatment of the network load at the local level under Schedule 21 be basically develop a way to make these definitions consistent. With regard to your question about 755 and whether that is inconsistent, I have not heard that. So if your questioner can point me to that, that would be helpful for our study and recommendations, but I have not heard that it's inconsistent with 755. I see it as a difference between the tariff definitions and the Rule 21 definitions. So anyway, it's an ambiguous topic that we are trying to delve into and address and offer a recommendation.
Okay, thank you. Here's a question about a 2-megawatt storage asset that CES is managing in ISO New England. Questioner wants to know if you could summarize that asset and what services it's providing.
We can talk generically about the services we provide, but no, I'm afraid I can't comment specifically on any individual asset. Basically, we provide the scheduling, settlement, telemetry services that we talked about in the operations part of the presentation, where we have a generation management system of our own. That generation management system is connected to the various ISOs, so we can pull the telemetry information in here and then disseminate it very quickly to the facilities that we manage. Through our Market Operations Center, we can submit offers into the various markets and be monitoring the clearing results, updating the availabilities to the ISOs if needed, and then also providing the shadow settlements function.
Okay, great. Somebody wants to know whether COMETS is a proprietary set of tools that only CES can use, or do you license these to others?
They are proprietary, but we also license that. So some of the modules are web-based, and it can be accessed.
Okay, great. Can you list issues that degrade performance factors such as capacity mismatch, telemetry failures, or latency, ramping, etc., in order of frequency? Wow, that's a big question. I don't know if you have that off the top of your head, but anyone want to take a shot at that?
So duration of the storage asset affects performance score because if the signal stays on one side quite a bit, then too short a duration asset gets full or empty quite quickly, and that affects the performance score. So other than the things that you already mentioned, the duration could be a big factor. In certain markets, the power rating also may affect, but in most markets, that does not really affect the system. But the in general accuracy of your BMS or also the inverters, that also affects the performance score.
Okay, good. And I think this is our last question, so we actually are addressing everybody. This is great. Does CES provide 24/7 monitoring and management of storage assets to respond to ISO requests?
Erik here. Yes, we do. The operations center we have is constantly monitoring both the ISO electronic signals and the response of the facility. We also pick up on phone calls or manual dispatches from the ISOs, and then we also will monitor for alarms or abnormal conditions at the facilities. For example, we pull smoke alarm information, high-level state of charge alerts or other faults at the facility, and then we can dispatch a third party out to the site if needed.
All right. Well, that's it for our questions today, and we've gone a little over time, but I appreciate everyone sticking with us. Thank you so much to our speakers. And Samantha, I'm going to just let you wrap this up with any announcements of upcoming webinars.
Thanks, Todd. So we don't have any upcoming webinars currently on the books, but we do have some that will be announced soon. So check our website, cesa.org/webinars, for news and information about that. And also on your screen, in addition to that web address, you'll see some other links where you can find more information and resources from STAP and some contact info for the hosts of our webinar. And thank you, everyone, for joining us today.
Okay, thank you. Bye-bye.